I was going to ask. So many people put up their hands anyway. A couple, and another question is, myself and a colleague gave this pretty much the same talk at the Java user group about a month ago. Was anyone at that? Okay, that's grand. He goes to all the talks anyway. So this is going to be a bit of a whirlwind tour of Scala and just some of the stuff that it offers, especially as a functional programming language. So I don't have much time to go into some of these concepts in detail, so it's just to kind of try and give you an overview. There's going to be a lot of code examples in this, so definitely stop me along the way if there's anything, if you have questions about or anything. So just to introduce myself, so my name's Tom, I work at NewsWeaver. You can get me on Twitter, prior TD there. At NewsWeaver, we have an internal communications platform. So large organizations use that to set up email campaigns, and recently we've launched an analytics reporting application which does big data analytics on these email campaigns, and you can you can run sort of cross-section analysis and look at the amount of clicks and things like that you're getting per segment basis. So you might look at employees in sales in Italy or something like that. So this is where we've really incorporated Scala, because we're using Spark to do all this, and Spark is written in Scala, and the Scala API is really, really nice to use. But also, apart from that though, with distributed computation as well, the functional programming paradigm is really, really suited to distributed parallel computations, where you're taking mutable state out of the equation and you're really making your systems a lot easier to reason about, which I'll kind of show as we go on. So yeah, it's the kind of four main areas that I'm going to just go into and show some examples on. So the Java interoperability would have been a JVM language, how it shines as a functional language. It's actually a hybrid language. It can be used as an object-oriented language as well, but I think to really get the maximum benefits from it, using it as a functional language is probably the way to go. And also going to show some static typing, gets back to some of the stuff we were just talking about there, and I'm going to show some of the conciseness of Scala as well. So first of all, being a JVM language, so the JVM's been around for a couple of decades now, and it's a really great platform in terms of memory management and garbage collection. So you're going to get all those benefits out of the box. But also, along with all that though, you're getting like reams and reams of libraries that have been around and tried and tested for years, and these are really easy to call from your Scala code, as I'll show now in an example. So you can straight away use your math libraries and your string utilities and things like that, so you don't have to go reinventing the wheel. And then it's also quite easy as well to integrate Scala with some other frameworks, like we're using Drop Wizard in NewsWeaver. And then you've got, as I was saying, you've got some platforms written in Scala, like Spark and Akka. And so the interoperability is pretty handy. So just show an example here. So just to look at some code. So this is some Java code here. It's kind of simple enough. Couple of classes there. So we've got this music library class and the album class, and there's a one-to-many between the music library and the album. So the music library has a property albums, which is a list, and each album has a title. So just say we wanted to use these POJOs in some Scala code. So you can actually have your Scala code and your Java code side by side in your IntelliJ project or your Eclipse project. There's a plugin for Gradle and Maven to allow you to do this pretty easily. So if we had so here we've got some Scala code. So first of all, just to explain a few of the concepts here. So object here it's more like a namespace, really. Like it's like a holder of your functions related to your music library. So in functional programming, it's kind of turning object-oriented programming inside out a bit. So you're kind of pulling the behavior out of your objects, and you're separating out your data structures into pure immutable data structures. And then you have your transformation functions that act on these data structures. So it's almost like passing data through a pipe and then getting out a result at the other end. So that's what's happening here. So I've got, I just want to add an album to the music library. So you can see really easily that I can reference the music library Java class and the album Java class with no rigmarole or anything, just straight in there. It's really handy, and I can even return a Java class there from the Scala function. the only extra bit here is in that previous Java code I was showing you, the albums, the list of albums is a mutable list. So it's kind of nicer to convert that to a Scala immutable list. And that's also another benefit of the interoperability here, that we're abstracting away the mutable state of the music library, and we're abstracting that behind this Scala function which is going to be more pure and immutable. So, so in order to convert from the Java collection to the Scala collection, I have to import Scala collection Java converters up here, and then I can literally just call as Scala on my Java albums collection, and then turn it into a Scala list. And you can see here I'm returning like a brand new music library, and this little double colon here, that's kind of the idiomatic way in Scala of adding a value onto a list. So really you're actually creating a new data structure there, which is going to contain the same values as the original data structure, but it's going to have this extra value added on, the extra album value. There is some smarts under the hood there, which allows, with persistent data structures, allowing some of this stuff to be shared underneath the hood for efficiency and just to reduce memory overload and stuff. So moving on then to Scala as a functional language. So just a few kind of main areas that Scala really shines as a functional language. It's got everything you need really that you'd want in a pure functional programming language, but it's pragmatic at the same time with its Java interoperability. So it's got immutability, functions of first-class citizens. You can just pass functions around as values. It supports all the usual idioms and patterns, which I'll show now in a minute. It's got pattern matching and then lazy evaluation, which is probably my favorite feature. So let's just start with the immutability. So say we had Java and we wanted to make that album class, we wanted to make sure it was immutable. So there's loads of kind of rigmarole we have to go through to do that. So first of all, we'd have to declare the title property as final. So that means that it can't be assigned to a new string once an instance of this class has been instantiated. And there's a subtle thing here as well, if anybody's read the Concurrency in Practice, the Doug Lee book. Another reason to make that final is that it's just to avoid a partially constructed object being used by a thread, which is a subtle thing that can happen if a thread escapes, or if the object escapes during the creation. But it's probably a whole other talk you could do on that. But as you can see anyway, I've no setter here. I just have a constructor which takes the string title, assigns it, and then just a getter to get the title. So I'm essentially making the class immutable, so the state can't change for any instances of this class. So to do all this then in Scala, it's just a little bit easier. You go from about 6 lines of code down to 1. It's only 5 words, basically. So Scala has this concept of case classes. So a case class really essentially is an immutable data structure. It can almost be thought of as a map with a property to a value, which is immutable, but you can also give it a type as well. It does give you the usual sort of functionality of classes too, in that you can add functions to your album class here. So if you had something that was always going to be needed on an album class, something really common, you might add it in there. But usually I'd try and keep the data structure separate and just pass them through pure functions instead. But anyway, so that's how easy it is to make your immutable data structure in Scala and retain your type information. And I'll show later on, you can use this then in pattern matching as well, which is a really handy feature of functional programming and of Scala. So then, one of the other key things of functional programming is allowing you to treat functions as first-class citizens, like so. So functions, they can be treated like any other value, and they can be referenced with val. Val is just basically how you just declare a value in Scala. They can be passed as parameters to other functions, making higher abstractions. They can be returned from functions, and they can be namespace members. So I know if you've done any Java before, like you might be saying, Java 8's got lambdas, like so. And I was thinking this myself maybe a year and a half ago or so when I was first looking at Java 8, and I was kind of thinking, sure, maybe I won't bother learning Scala. If Java 8 is going to get in some of this stuff, but that was before I kind of went deeper into functional programming languages, and I realized that Java 8 is still far from being a fully featured functional programming language. It's still missing a lot of core features that you'd want in a functional programming language. But also, there's extra kind of rigmarole you have to go through in order to use lambdas in Java 8. And by lambda, I just mean it's just where you declare an instance of a function just using, like, you just declare the input and then the function body with an arrow in between. I think I had a slide on that, but I think I took it out to try and make this talk more concise. So anyway, so we just have this triangle class here, so it's got 3 sides, side A, B, C. So this is a really contrived example, like it's probably not how you do something like this, just for demonstration. So we've got this transform triangle function, and we want to pass in another function just to tell this how to transform it. So, so in order to do this with Java 8, we have to declare a functional interface, which is an interface with one abstract method. And then if we want to kind of pass in what's essentially a converter function, it has to be an instance of this functional interface. And then to call that function, we have to call it through the object reference, through converter.convert. So it's more like really wrapping functions inside objects and passing them around, which could be how Scala is working underneath the hood, but at a conceptual level, Scala definitely is a lot easier in that it lets you think of functions more as direct values. Like, so what was I going to say? Yeah, so I'll just show the Scala example then. Oh yeah, so yeah, another thing there, just these functional interfaces. There is like a lot of functional interfaces in the Java 8 standard library, like, so, you know, so you could be covered a lot of the time. You mightn't have to create your own custom one, but still, sooner or later, you're going to come across a situation like if you want a function with 3 parameters here, where you're going to need a new functional interface, and you have to go through all this stuff to be able to pass in a functional parameter. So this is the same thing done in Scala. So I've taken out the functionality out of the triangle class. So I've got an immutable data structure case class here, like I showed before, with the 3 sides. But now, in my transform triangle function, for passing in the converter function, it's really straightforward. Like I can declare my function without having to declare any functional interface or any stuff like that. I can declare the function type by just specifying the input type parameters and the output type parameter. You know, really straightforward, and I can just call this function directly inside here, just calling converter. I don't have to go through any object reference or anything like that. So it's definitely way more idiomatic functional programming. So a lot simpler. So yeah, another cool feature then of functional programming is pattern matching. So this is where you can basically do a check on a value and check if it matches a certain type. And then also you can deconstruct that data structure and extract little parts out of the data structure. So it's called destructuring, or it's like the opposite to a constructor. It's like destructuring. So you can see in this case, so we've got this method, we just want to get the title of the album. So we can do a match on the album parameter, and we can say, okay, if this is of type album, I want to just reach into the data structure and get out this title property. And this is a simple example, but I'll show another one now where you can even destructure on nested data structures, like nested objects. So in this example here, so we can just say we have this function that it's going to take an album, but we want to make it optional whether you can pass in this album or not. So this is like optional in Java 8, if anybody's seen that. So option is just like it's a type in Scala, and concrete subtypes of this. There's only 2 concrete subtypes. There's either some or none. If it's none, it means it doesn't contain anything. If it's some, it means it will contain the parameterized type album here. So this is where pattern matching gets even more powerful, because now we can match on the actual concrete types. So now we can just say if the actual type of option is none, just give me back the empty string. If it does actually contain something, then I want to destructure this whole thing. And so you can destructure the nested data structure there as well, and reach right in there and get out the title property. So it really makes for really concise code. And you know, if you imagine doing something like this in a more imperative way, it's going to be a lot more ugly to do. And you know, this is really easy to read. And once you kind of get used to the pattern matching idea. So another thing then with Scala, so you get all the usual kind of functional programming idioms and patterns. So, so in functional programming, it's more about this declarative approach. So say if you want to write a simple loop, in an imperative approach, you're going to be writing maybe like a for loop with a mutable loop counter. But in functional programming, you want immutable state. So it's more idiomatic to use recursion. So you can actually, it's almost like you can do a loop, but you can pass in immutable values to each step in the loop by just recursively calling this go function. So then this is just a factorial function. It's just going to take a number n and just get the product from n down to 1. So this would be more of a standard functional programming approach. So I'm just have this kind of looping function here, which I'm calling recursively, and just passing in n minus 1 each time. And I've got this accumulator, which is just multiplying the product onto the accumulator for each function call. So the thing is with this though, you're able to do something like this with like a massive data collection because Scala supports tail recursion, which is something that Java and a lot of other object-oriented languages mightn't give you. Well, Java doesn't give it anyway. So tail recursion just means that a recursive call can reuse the same stack frame. So it can only do that if it's able to evaluate all its arguments. So if this call to go here, it knows how to get n minus 1 and it knows how to get n multiplied by the accumulator. So it doesn't need to recurse any further. So it can directly make another call to go, and so it can just reuse the same stack frame then. So what that means then is that you don't get a stack overflow exception if you've got some massive big data collection. There is, if this was implemented a different way and Go was recursively calling Go inside here, it wouldn't be tail recursive. But with this annotation here, the tail recursion annotation, the Scala compiler will tell you if you think that you're writing a function that's tail recursive that isn't actually tail recursive. It'll flag that for you, so which is kind of handy. So just continuing on with the idioms and patterns. So most of the time, when you're doing functional programming, a lot of the time you're probably not going to have to write primitive loops like that in primitive functions. Functional programming is all about implementing really simple, pure functions, starting off at quite low levels of abstraction and building more and more levels of abstraction on top of them with more and more pure functions. And so Scala gives you all those functional programming type, like functional programming functions out of the box, like you'd get in any functional programming language. So one of these would be like fold left. So essentially, that's doing what we saw on the previous slide. It's going to be underneath doing something like going to be doing something like we saw on the previous slide with a tail recursion underneath. But it's a lot easier to once you know kind of what fold left does, and once you get over the learning curve of functional programming in Scala, it's very quick to look at that and just see we're going 1 to n and we're just multiplying up. So the underscores here are just some syntactic sugar to make the code more concise. So that's really equivalent to just a function that takes 2 integers and returns the product of the 2 integers. So next, yeah. So then I suppose the next key feature then with functional programming and Scala and where it really shines as well is lazy evaluation. So lazy evaluation then is a concept where a lazy value will only be evaluated if it is needed by a computation and when it's needed. So if it's never needed, it won't be evaluated. And there's other languages like Haskell that'll do this by default. In Scala, you have to explicitly declare that your value is going to be lazy. So, and then you can have lazy functional parameters, which are often referred to as thunks, and that means that they're called non-strict function parameters. And so just to show an example, so this would be like just a usual function with no laziness or anything. It's just a strict function. So it's taking this expensive evaluation string. So I'm going to pretend that this is really expensive to evaluate, that it's like, I don't know, going out and processing 1 million records or something like that. And then it's just going to take this integer. So it's a really simple function. If the integer is less than 2, it's going to just print, it's going to return less than 2. Otherwise, it's going to return the result of the expensive evaluation that it gets as a parameter. And then I'm just calling this function in a main method here. I'm passing this little evaluation block, which will which when evaluated is just going to print out I'm evaluating something expensive, and then I'm passing in 1. So because the number is less than 2, it's never going to need to execute the else part of the if else, but you can still see that it does evaluate the expensive evaluation. You can see in the output then you've got executing expensive evaluation. So even though this string is never going to be needed anywhere in a computation, it still gets evaluated. So it'd be nice then, if there was a way just to say, just only evaluate me if you need me to. So you can do this really easily in Scala then, with just this little bit of syntax here, just this equals in the arrow. So that's what's commonly called a thunk, or it's kind of syntactic sugar for just wrapping this in a function that may or may not get executed. So you can see here now that it's not evaluating the expensive evaluation, it's just printing out less than 2, and because it doesn't need to execute the else part of the if else, so that doesn't get evaluated. You can do it a slightly different way. You can also have lazy vals, which is this declaration here. So when you're declaring a value, this expensive evaluation, you can just declare it as lazy, and then Scala will treat it as lazy, and it'll only evaluate it if it's needed. So again, you pass in 1 less than 2. Doesn't need to evaluate expensive evaluation, so we never see it getting evaluated in the output. And the other advantage to that is that it'll cache the result of that evaluation. So if it does finally need to evaluate that for some reason, it'll cache the result. So if it ever has to be evaluated again, it has it in memory. So if it's a really expensive evaluation, it's going to be pretty efficient to be able to cache that. So I suppose that's all the stuff there about functional programming. So some of the other advantages of Scala, it's a statically typed language. So yeah, there is this big debate around static and dynamic typing, and I don't know, he could talk all night about that. They both have their advantages really. But I think where Scala really shines is in its type inference. So you can see this a simple enough function here, just a list of integers, just converting it to a string, a comma-separated string. So here we're explicitly declaring all our types. So we're declaring that it returns a string. We're declaring that strings is going to be a list of parameterized type string. But we actually don't have to do any of that. So Scala can infer all that for us. So we don't even need to declare that this is returning a string. Anything that calls this function and assigns it to a value, Scala will be able to infer that that's what the type is. We don't have to infer it, we don't have to declare that we've got a list of strings here. It's going to infer that. But what's more as well, it's actually it's actually inferring the parameterized type of the list of strings as well, just because we've passed in this function into the map. So it knows that we're going to be converting this to a list of strings. So it's really quite sophisticated there. Yeah, I suppose just getting back to that, like sometimes you may want to explicitly declare your types though, like, it's for readability purposes, but I think in this case the function name says it all, and there's no real advantage to be gained by declaring your types there. So yeah, another huge advantage then is the conciseness. I don't really have a specific example around this except for this kind of jokey thing here. But yeah, hopefully throughout all the examples there that you've seen, like just how concise the Scala code can be. This is probably a bit unfair here because with Java 8 you could probably make that a bit more concise, but still.
Does the Java programmer have grayer hair?
He's what?
Does the Java programmer have grayer hair?
Maybe, he probably does. Yeah. Yeah, so then, I suppose just to finish up then, so learning Scala and introducing it to your team. So, it's different ways, like any programming language, it's very easy just to download Scala and get a REPL up and running that's read eval print loop. You can run it in your terminal and you can put in Scala expressions and just run them and play around with the syntax. An idea might be just to take some Java code and try and re-implement it in Scala. I just have to be aware of vars here because, as I was saying earlier, like to really get the benefits of Scala is to use it as a functional language. So vars they're like vals except they're mutable. So if you want to use a pure functional programming approach, you'd want to avoid using vars. And So what I mean, you can do katas like, programming problems. There's this website exorcism.io, which has loads of programming problems in loads of different languages. Just kind of, you can have some fun on that. And just books, and there's a really good Coursera course as well. The creator of Scala, Martin Rodersky, he's got a course up there. So the books then, I'd say these are kind of probably the three most popular: the Functional Programming Scala, and the kind of red book, as some people call it. That's a really great book just for learning functional programming concepts. Really, it kind of uses Scala as a vehicle to teach functional programming. It teaches you enough Scala just to show functional programming concepts. So it's a long one. Like, there's a lot of exercises in it, and but if you really want to dive deep into functional programming, it's amazing. The Programming Scala O'Reilly book, that's probably more, it's going to show you more about the syntax of the language and the structures and the different forms and stuff in the language. Like, so maybe you could have the functional programming in Scala going in the background, and then you could be reading up on the syntax stuff in the O'Reilly book. Atomic Scala, I actually haven't looked at it myself now, but it is a popular one, and it's meant to be pretty good as well. So introducing it at work then. So a good, like, kind of non-intrusive way is with unit tests. As I was saying earlier, you can have your Scala and your Java code existing side by side really easily. So you could easily start writing unit tests in Scala, and Scala can be especially handy for unit tests. If you're having to process results from tests that might be, large data structures, and it's going to make the test a lot more readable. The microservice idea as well. If you have a microservice architecture, you could try rewriting a Java microservice in Scala, or writing a new one in Scala, or write one in Scala and Java and compare them. The book club idea, that's something that we've been doing in Newsweaver with the Functional Programming in Scala book. So we've been going through the exercises, and we've got like a Git repository that we'd post up our solutions to, and we can submit pull requests and help each other out and put up comments on that. If you're big into JavaScript, there is this Scala.js. To be honest, I don't know much about that yet at the moment, but it's a way of compiling Scala down to JavaScript to run in the browser. And then if you're using any sort of distributed computation, big data sort of analytics type systems, like it might be worth looking at Spark, and definitely Scala would be a good choice to use there. Then lastly, so just some resources as well. So Twitter have this pretty cool website, Scala School. That's cool actually, just for as a quick reference to the different syntaxes and stuff in the language. So if you're going through the Functional Programming Scala book and you come across something that mightn't be explained too well in terms of the syntax, the Scala School is really good to look up and have a look at. There's a functional programming group that's set up in Cork. They're yet to have their first meeting, but hopefully that will get going soon. This guy actually has got a really good blog about Scala and functional programming. He's just got a series of tutorials and stuff, so you could go on there to his website. He's got some really good explanations. So yeah, that's it.
Speed difference between Java and Scala?
That's a good question. Maybe in the build process, but in terms of performance, I haven't really done a side-by-side performance check myself. So, I don't know. I know, like, I was reading a bit about streams in Java 8, and I think, say if you're looping through a collection, if you write just a primitive loop with a for loop, I think that can be more performant on just like a simple stream. But then again, where functional programming really shines is with lazy evaluation. And if you start going deeper into lazy evaluation, you can get into the idea of lazy streams and infinite streams. So streams where one value will just compute the next value and the next value. And you can build up really complex computations on these infinite streams, like really complex functional pipelines, which is just going to be, really, really performant just simply because of the laziness of the stream. yeah, I suppose in a simple list side by side, maybe just a primitive for loop is probably going to be quicker. Like, yeah.
I think one of the advantages performance-wise is that you can run out the multiple cores or multiple threads.
Yeah. Well, that's it. Like, you know,
if you have a 16-core server,
yeah.
and your application is like, you can only run on one core. It's very nice, but and so with Scala usually you can run on 16 cores.
Yeah, I mean, it does make, it makes multiple core, multiple.
So it's the same speed probably, but you can run the multiple cores.
Yeah. Well, with the functional approach, you know, it's a lot easier to write distributed computations and multi-core concurrent computations and stuff.
Pure functions, is that where that happens? Or?
Yeah, it makes it a lot easier to reason about, and you're not dealing with shared mutable state as much, and you don't get caught up in having to protect your shared mutable state and locks and synchronization and all that sort of stuff. And then there's frameworks that are kind of built on this a bit, like Akka, which would be using the actor pattern and stuff like that. So, which makes multi-threaded programming a lot easier to reason about. And
have you come from a different functional programming language, or Scala your first?
I first got into functional programming through JavaScript, really, actually, a few years ago. That was the first time I saw how cool it was to be able to just pass functions around, like, you know, and then I kind of went deeper into it, and I spent a good while learning Clojure, because I wanted just to learn a pure functional programming language, like, and just loved all the concepts and just fell in love with it, really, like, and I'm still learning, like, I'm still trying to go deeper into learning about functional programming, but the deeper I go, it just really seems like such a I don't know if better, it probably isn't the right word, but for me it seems like a better way to do things. You know, it just seems so much easier to reason about your systems.
Would Scala be a better bridge, say if you're coming from like JavaScript or Java, or even C?
Yeah, if you're coming from if you're coming from a C type language, it might be easier. With just Haskell as well. Yeah, I don't know. Yeah, I suppose if you're coming from something like Java, maybe Scala might be a bit easier to get into. With just Clojure, but it's a Lisp, but it doesn't take too long to get over the fact that it's a Lisp and appreciate that it's a Lisp. So, but I suppose if you want to stick to a C-like syntax, maybe, yeah, it might be easier, yeah.
Does it integrate well with various bits of tooling that would have been built for Java and the JVM?
Yeah.
Like, you know, your kit for performance profiling and things like that. Maybe you don't even need to really do.
Yeah, I haven't done that too much now, but I'd imagine it would, like, 'cause it's just it's running on the JVM, so it should really, you know, it compiles into bytecode, so it should run. It should be okay with those sort of tools, like, I'd imagine. But definitely, when you're using libraries and stuff like that, it's pretty easy to use Java libraries, and sometimes it gets a bit annoying because sometimes the Java libraries wouldn't be written in a functional sort of way.
Yeah. So
you're kind of having to abstract things. We use this tool called wart remover, so it flags if you're not doing something in a good sort of functional way. Okay. So sometimes when we're using that with existing Java libraries, it can kind of get a bit hard to get over some of the errors and stuff.
Just review lines everywhere. Then.
Yeah. So, but yeah, no, it's not too bad.
Okay.
All right.